In this video, we are going to solve systems of inequalities, and the only way to solve the system of inequalities is to graph them. So, here is a system of two linear inequalities. We have prepared coordinate plane, and we are going to take one by one those inequalities and pretend first that those are not inequalities, that they are equations. So the first inequality is actually y equals negative 3x plus 4. And next thing what I'm going to do, because I'm afraid that I'm going to forget, I'm going to pay attention on the sign of the inequality. I see that the sign is actually negative, it's greater than or equal to. And if sign is greater than or equal to, it means that the line that we are going to graph is going to be the solid line. And I'm going to put this like a reminder for myself. Now, in order to graph this line, we can notice that the line is in the form slope-intercept form, and therefore we are going to use the y-intercept, which is 4, and the slope, which is negative 3, to graph the line. And we are going to write down negative 3 over 1, because the slope is actually rise over run, and this is what we need. Rise over run. So, to start graphing, we have to find the y-intercept first. It's right here. Negative 3 rise means that we have to go down 3 units. 1, 2, 3 right here. And 1, which is run, it means we have to go 1 unit to the right. And here is the next point. Now I'm going to go down one more time, 3 units, and 1 unit to the right. Here is another point. And you can clearly see that all 3 points are on the same line. So we did everything correctly. We have to draw the line through these 3 points. Here is the line. However, this line is a solution for this equation. All points around the line are solutions for the equation, but not for the inequality. This line divides the plane in two half planes, and only one of them is the solution. Now, which half plane, this one or this one, from this side of the inequality? In order to decide, we have to test the point. You can test any point what you like, but I'm going to use the point with coordinates 0 and 0, the origin, because it's just simple computations that involve 0 and 0. So we are going to test the point with coordinates 0 and 0. And we're going to plug it in instead of x and y. So we will have 0 greater or equal to negative 3 times 0 plus 4, which is going to give me 0 greater or equal to 4. Now the question is it true or false? And it's clearly false, and it means that this point, 0 and 0, is not the solution of the inequality. And neither other point on this half of the plane, whereas 0, 0 is the solution of the inequality. So this half of the plane is the correct one. And we are going to shade this half of the plane. So here is the shading portion. And we are done with graphic of the first inequality. Now I'm going to erase this. And if you remember the very first step what we did, we pretended that our inequality is not an inequality but an equation. And for the second one, we are going to do the same thing. We are going to take and change sign from less than to equal. But of course, you are going to keep in your mind that basically this sign was less than, and therefore when we are going to graph the line, we are going to do the solid line. Now, our equation is in the standard form, not in the slope-intercept form. And in order to graph the line, it's usually easier to use the table of values. This is x, this is y. And what we are going to do, we are going to ask ourselves a question. So let's say if x is 0, what is the value of y? No, okay, so if x is 0, the whole term right here is 0, and 3y equals 12, so y must be 4. Now, let's pretend right now that y is 0 right now. So if y equals 0, what is going to be the value of x? But this term right now, 3y, 3 times 0 is just 0. And what is left is 2x equals 12. So x must be 6. Now we can test one more value. Let's say if x is 3. Okay, it's a little bit more complicated. So let's plug it in. 2 times 3 plus 3y equals 12. So this is 6 plus 3y equals 12. And 3y equals 6. And y equals 2. So now we have 3 points that we can graph. So this is the first point, 0 and 4. Here is another point, 6 and 0. And last one, 3 and 2. And let's graph them. So 0 and 4 is this one. 6 and 0 is right here. And 3 and 2 is right here. Now we are going to draw the line through them. And the line must be the dashed line. So it's right here. And again, we are not done yet because we need to figure out which half plane is correct one. This one from this side. Oops, I'm sorry. Let me put it back. Or from this side of the line. In order to do it, we are going to test the point. And since I really do like point 0 and 0, I'm going to test it one more time again. So we test the point. Test the point with coordinates 0 and 0, and to do so I'm going to plug it into inequality. 2 times 0 plus 3 times 0 should give me less than 12. Okay, let's check. The left hand side is 0, less than 12. Is it true or false? Oh yes, it's true. It means the point 0 and 0 is the solution of this inequality and all other points on this side of the line. So now I'm ready to shade this half plane. And I have my shading prepared. And where you see those shading parts, they overlap, this portion is the solution. So I can even highlight it so you can see it better. So this portion right here, where they overlap, it's actually the solution of the inequality. We are done. In this video, we are going to solve a system of inequalities, and the only way to do it is to graph them. So here is the system of two linear inequalities. Here is the coordinate plane which we prepared. And the first step to do it is to pretend that the first inequality right here is actually not an inequality, but the equation. So instead of the inequality sign, we have the equal sign. And we have to graph first the line, because this is the graph of the line. Still, you have to keep in your mind that actually the sign of the inequality is greater than or equal to, and it means that the line is going to be the solid line. So I'm going to put it right here as a reminder that I'm going to graph the solid line. And since this equation is given in the slope-intercept form, we are going to use y-intercept, which is 4, and slope, which is -3, to graph the line. So y-intercept is 4, slope is -3, and it's easier to write down -3 over 1, because basically what we need for the slope, we need rise over run. And we are ready to graph the line. Y-intercept 4 is right here, here is the point, -3 over 1. So rise -3 means go down 3 units, 1, 2, 3. Over 1, 1 means go to the right. So here is my next point. One more time, 1, 2, 3, down, 1 to the right. Here it is. And we have 3 points, and we are ready to graph the line. I have my line prepared, so let me just move it right here. And you can clearly see that we did everything correctly, all 3 points in the same line. Now, this line is the equation, is the solution of this particular equation, but it's not the solution of the inequality. The solution of the inequality is one of the half planes, either this one or from this side of the line. And to decide which one is the correct one, we have to test the point. We are going to test the point which is more convenient for me, and but it can be any other point, the point with coordinates 0 and 0. So we are going to test the point with coordinates 0 and 0. How we are going to do it? We are going to plug it in this inequality and see it's going to give me true or false. So 0 is greater or equal to negative 3 times 0 plus 4. And we will have 0 greater or equal than 4. Now the question is true or false? Okay, this is false. It means that this point with coordinates 0 and 0 is not a solution of the inequality. And all other points in this half plane is not a solution either. So all my solutions are right here. And if I shade this portion of the half plane, it's going to be a solution of this particular inequality. I have shading part also prepared. Now let me move it over here. Oops. Almost there. Doesn't want to go, for what reason? Oh, now it's perfect. Now we are going to repeat the same procedure for the second inequality. So let me erase what I wrote here. And if you remember the first step, what we did, we pretended that this inequality was actually the equation. So I'm going to take this equation and graph the line. One more time, it's not inequality sign, but it's less than sign right here. If it's a less than sign, it means that I'm going to use the dash line, and I prepare my dash line right here. Now, let me write down on the top so we will not forget it's less than sign, right? And to graph it, it's not a slope-intercept form, it's a standard form. And what I suggest to do is to use the table of values. So we will prepare x and y, and here is how we are going to think. What if x is going to be 0? Then what is the value of y? If y is going to be 0, what is going to be the value of x? So if x is 0, the whole this term is going to become 0. And 3y equals 12, y must be 4. Now, what is going to happen if y is going to be 0? So if y is going to be 0, the whole term 3y is going to vanish, and 2x equals 12, and so therefore x must be 6. So now we have 2 points, 0 and 4, points 6 and 0, and 2 points are enough to graph the line. Now if you want to double check if everything is correct, try another point, try another number. So for example, I see that if x, let's say, let's make it 3, and solve for y, what is going to be the value of y? So let's plug it in. 2 times 3 plus 3y must be equal to 12. So 2 times 3 is 6. 6 plus 3y equals 12. And minus 6 from both sides, 3y equals 6, or y equals 2. So here we have another point. Now let's graph those points. So 0 and 4 is right here. 6 and 0. 6 and 0 is right here. And 3 and 2 over there. And we are ready to create the line. So here is my line. I do know it's supposed to be the dashed line, so it's a dashed line. My line doesn't want to move, but we will do it eventually. Now it fits perfectly. And we need to find the solution of the inequality, because the line is a solution of the equation. And what we are going to do, we are going to test the point. I'm going to use the same point that we already used. So we are going to test the point with coordinates 0 and 0 and again. And if I plug it in, I will have 2 times 0 plus 3 times 0 equals 12. Not equal to. We need less than sign, right? Less than sign. Less than 12. Now, the whole left-hand side is 0, less than 12. Is it true? Yes, it's true. If it's true, 0 and 0, this point is the part of the solution of this inequality, and all other points. So we need shading for this. And let me move the shading right here. So here is the shading for this portion. And you can see that where those shading portions, they overlap, the overlapping portion is the solution.